Greetings, salutations, and welcome back to another video. Now, as promised, this video will be on linear rail and guide systems. Last time we talked about the actuators such as belts and lead screws, but this time we're going to be talking about the things that they run along. So, for example, here I have my Hephaestus, and this beauty is printing its own upgrades, which I'm hoping to do a video on soon once that's all ready to go. So the first example we have are these very simple shafts. These are 8mm shafts. They take LM8UU bearings inside the carriage. I'll show you a photo of those later. Here we have V-slot. Now, V-slot is an aluminium extrusion. I'll show you again some other solutions I have, but you tend to get them with these little wheels, Delrin wheels, that run along the tracks. Now, I've been experimenting with using little bits of round PTFE to run along the grooves instead, and soon hopefully I will be able to do a video on that once I upgrade this system. So here we have the carriage of the Axis CNC, and I shall be doing more on this soon. I want to get this video out of the way so I can update you more on what's actually been happening. These are 12mm shafts and LM12UU bearings. The 12 obviously is the diameter, and LM just means the linear motion. And there's a few other little bits that come in handy when you dig deeper, but that's the basic premise. And now I'm actually running this along V-slot. I have here a test piece of V-slot, and here's my other solution. I'm using basically a Y or omega shape to run along using those bearings, because the wheels, which I showed you in the previous clip, cost about £4 each or something ridiculous like that. They're ridiculously expensive. But by using cheap bearings like this, you can, oops, lost it. You can get a really smooth motion at a much lower cost. I got 20 of these for about £10, so that's really quite a lot. So linear rails tend to be decently cheap. You want to go for a steel, preferably a stainless or in fact a silver steel, the silver steel being a very much hardened tool steel. Now these I believe are silver steel. I got them from the old Rapman. And just to demonstrate, as I previously mentioned in the last video about rolling things to test their flatness, you can see that one's got a very good roll, but this one, which I've marked with red because it isn't good, just a bit hard to see, but yes, see there? You can see the sunlight coming through at the bottom there. That's because it's got a very bad bend in it, and so that isn't really good for actual linear motion. Now, with the V-slot, you get them in different unit lengths, a unit being one of these 20 by 20mm segments. So this is a 20 by 40, and that tends to have a lot more stiffness than obviously the 20 by 20. So that's what I'm using for my Axis machine, because I need that extra strength for the extra weight and forces that are being applied by the CNC. Now, what happens with V-slot usually is, if we draw a basic profile like so, that is a very bad profile, but they have little Delrin wheels, as I showed you on Hephaestus, that basically clamp on either side, like so, and run it along the axis there. Now what I'm doing on Hephaestus next is I'm going to be experimenting with Delrin, because, sorry, PTFE rods, because these Delrin wheels cost about £4 a piece. They can come down to 32p each if you're willing to buy 200 of them off AliExpress, but I'm not. I don't need 200 of those things. So what I'm going to be doing is I'm going to be using PTFE tubes or rods like so, and they're going to be clamped onto a piece of V-slot like that, and I can vary the tension there by using different amounts of springy material. Just act as a shock absorber, but the idea is that that is a low friction running, and it should be just as good, if not better, than the Delrins at a much cheaper cost. These, for about 250mm, the rods cost roughly £8, so that's a lot better than the wheels. Now the final thing that I'm doing, as I showed earlier, and just to explain it a bit further, is that on my Axis machine, because it's taking a lot more load than the printer. The printer only needs to move the little head and the extruder motor, and that's a very light assembly. compared to basically the spindle, the huge motor, like drill-like motor, that cuts the wood or the material, plus the Y assembly to move it, plus the Z assembly to move that and all that. It's just a lot of weight. So what I'm using instead is a bearing system that uses 2 bearings at the top to take downwards load, and that should be the majority of the load from the mass. But then here, at an angle running on these V's here, I have another set of bearings that are taking a decent amount of lateral load as well as a tiny bit of upwards load for when it's cutting and it's actually pushing down into the material and thus pushing the rest of the assembly up. So those are the 3 methods I'm using there. V-slot tends to be decently expensive, but to be honest, for the amount of potential that it's got with all of these different features, it's really well priced, especially when you consider that a piece of box segment aluminium extrusion, you know, the hollow segments like so, of the same size and length, costs £15 as opposed to £20 just about. So you're not doing very badly there. You can use the box section. What I would suggest is using wheels or bearings like so. But yeah, use bearings there along axes like this, and probably some retainer bearings on either the outside or the inside like so, just to box it in. Now I have seen one system that uses a pair of bearings like so on the corners and just a washer in between to distance them, and then kind of squeezes those across there. However, I don't feel this is very secure because you've only got the corner here impacting on a flat surface and it just doesn't feel rigid enough, but that is another solution. I would always go for these and lay them with that being the that being the horizontal and that being the vertical, because you want to take as much load here, and obviously that section there is going to take more force than if it's laid like that. So for example, a very long piece of this would not bend as easily this way as it would that way. Now there are a few other aluminium extrusions that can be used. You can try using L-bar or right-angled extrusion like so. The rods that I mentioned earlier, these silver steel rods or stainless steel rods, they come in a few variants. You get the normal circular ones like that. You get ones now that have a supporting bar like so, and those are much more stiff and rigid and you can bolt down on much more easily. They're just more expensive, as is to be expected. Now I've also seen some linear rail systems that use basically a piece of extrusion like that that can be bolted down, and they use a carriage like so that has little ball bearings that clamp in there and they run along tracks. So here you've got the carriage and it just runs along the track using those ball bearings. Now that's a very, very nice solution. I think linear rail is what you want to be searching for to find that. I couldn't find any nice terminology for it, but that should get you a nice search if you go onto eBay. But those also tend to be quite expensive. So it's up to you what you choose. I would suggest that for heavy things like the CNC machine, you definitely use either box extrusion or use the V-slot. There's a lot more options there. But yeah, it's up to you. Now I'm going to end the video here. I'm going to go and work some more on Axis and show you a bit more about that in the next video. So thank you very much for watching, and if you know any more solutions or systems, please do comment them below. If you want to know more about any of these, do let me know as well. So thank you very much for watching, and I shall see you again next time. Goodbye.